Welcome to Scared Serverless, what we learned after ditching servers for a year. My name's James Beswick. I'm the co-founder of Indevelo, and we're a software shop that builds MVPs for startups. So we have two clients in Europe, and they fund startups when we build their technology solutions. So kind of product management as a service, if you want to sound fancy. I've also written lots of stuff on Medium, so there are all my contact details if you want to reach out or read any of my scribblings. So mostly what we've been building over the last 3 years end up being web apps or mobile apps. Not always, but usually those are the sorts of things that we build. And after 18 months of doing this, we went through the inventory of about the dozen apps we'd built up to that point. And what we found was that each one had its own separate stack. It was Elastic Beanstalk with EC2 instances, usually RDS, typically single region. Each one was Django or Flask usually, so you have the front end generated by the back end, so JavaScript living with Python. And a lot of duplicate code appearing. And this is because lots of code for authorization, database management, and multi-tenant management, because in MVP land, everything these days is SaaS, so you have to factor that in too. So each one of these created a series of problems for us. One was the inability to scale. And this is the biggest problem. So when you build an MVP, a minimum viable product, by definition, you're building something that's small to test. Now, about 8 out of 10 of these products fail, and 2 out of 10 of them succeed. And you have no idea which 2 will succeed. But when they do, you haven't built it to be production ready. So when it scales up, you end up frantically rewriting things and trying to make it work. And this is a long-term problem with building MVPs, but we're trying to figure out what's the best solution there. The second problem was our inability to scale as a business. So I was spending my weekends patching EC2 servers for projects that we were paid for and had been deployed. And I'm too embarrassed to let them fail. I'm just keeping them going. But I'm wondering how this is going to work when we get to 30, 40, 50 apps, and whether I'll have any personal life as a result. And finally, our apps are looking a bit clunky. So this is around the time that Facebook and Google apps are starting to make everything look real-time and slick. And our customers are expecting this even out of MVPs. So somebody mentioned serverless. And back at this point, what I knew serverless could do, I knew it could resize images. And yeah, that's pretty much it. Resizing images. So I didn't know anything about serverless. But I was invited to Serverless Conf in late October 2017, or early. And I went on a workshop where we built some video sharing websites very quickly. I did a hackathon where I saw about a dozen different apps come to life using serverless techniques. And most importantly, I saw a load of different presentations by some of the people who are here today that really opened my eyes to what was possible with serverless. You can build whole apps. And I was amazed by this, but I left with more questions than answers because I come from a serverful world. So if the server goes away, what happens to the auth? What happens to state? If I'm not building the web page in my Django app, then is Lambda doing that? What is this Lambda lifecycle? And then the biggest shock of all, oh, it's not just functions. It's other stuff too. So we dived into building a couple of apps. And what we found is our app design changed very quickly. So our initial pre-serverless app looked a bit like this. This is simplistic, but it's more or less right. It was an Elastic Beanstalk app with RDS, and we're treating the browser at the front as a dumb client. So the first step was to do the Lambda as monolith part, where you lift and shift using something like the Zapper framework. And congratulations, you've launched your first Lambda, but it's not really at all serverless. It's really the absolute least you can do. So once you get to this stage, the next most important part is to break apart this middle layer, figure out your business logic, and develop your series of REST APIs. But this introduces JavaScript. Now, we were all Python, so this was really scary for us because we thought about callback hell and everything else. And we went through a period of time where we were learning how to use jQuery and all this sort of stuff. And the front end started to become a real mess. Until we discovered single-page application frameworks. So there's React, Vue, Angular. It doesn't really matter which one you pick. We went with Vue. But this really tidied up the front end. And it made it much more like developing old desktop applications because it delineates the front end from the back end. Finally, we had to let go of RDS. RDS is one of those things where in many web app instances, you're better off with DynamoDB for reasons that are long and complicated, but it takes time to understand exactly how DynamoDB works. So it turns out this is actually a fairly common pattern for web apps now, but we really discovered it by accident. So the 6 things we learned in the process were, firstly, get your tooling right. So we came from Python, and we ended up being 100% Node in the end, which was a big shock to us, but it just made more sense when you're working with Vue.js and you're passing around JSON objects in the back end. Learn to get rid of the middle layer. So this is one of the really hard parts, that you're always building monoliths as a developer, and you have to really get used to the idea that this monolith at the back end is going away. That does take time. Use a SPA, a single-page application framework. Learn to love DynamoDB. Now, for a key value store, it's really hard to get your hands around. And we went through lots of tutorials and attempts to build it up and understand what we were doing, and we kept making mistakes. DynamoDB isn't what you think it is. It's not very forgiving, and it's not flexible, but it is very, very efficient. So if you understand your data access patterns and keep experimenting, you'll have good benefits from it. We almost gave up a couple of times, but I'm glad we didn't. We went with Serverless framework 18 months ago. Today, I would recommend looking at SAM because it's evolved a long way since then. But the key thing is you need one of these tools, because if you start with a Lambda IDE, you'll find it harder to bring it into the workflow that you're used to using. And finally, I think Ben said this earlier, but it's absolutely correct, outsource the auth. So auth is something where it's hard to write. There's absolutely no rewards for getting it right. There's only a horror show if it goes wrong. You should really look at Auth0 or Cognito. Auth0 is very easy to start with. It's just a couple of dozen lines of code. Gets you into the whole JWT concept fairly easily. And then with some of our more complicated apps, we went with Cognito in the end, just because it's more of the enterprise sledgehammer to crack the nut. So I took those 6 things I learned, and I threw them into an article, as I'm prone to do. And this thing went crazy. So in the first, I think that was 6 weeks, 100,000 people read this. I had over nearly 1,000 comments and questions from people from various corners of the internet, and it ended up being the #2 article on Cloud Guru in 2018. And this told me something. Not that I needed a career in journalism, but actually a lot of us were going through the same sorts of pains of going from pre-serverless development to this new serverless path. Now, it's been a few months since then, and we've built lots of stuff in the interim. So I wanted to extract some more lessons since that first article. So in the pre-serverless world, you're used to building a monolith. And now we're building a Rube Goldberg function, which you would see if this video was working. So the problem with this analogy, and it's an interesting one, is that a file lands in S3, it fires off a DynamoDB function, it calls SQS, and so on and so forth. So you're used to this idea of sort of chaos throughout the system. And so a Rube Goldberg machine seems like an apt comparison. But it's not a very useful one. And in fact, I don't think we're really doing that at all. In this OK Go video that you cannot see, it took 100 takes to make the video. And in real life, we're not building things where the ball bearing flies off and hits someone in the eye and burns the building down. We're actually making things that are very dependable. So I think a better analogy is that serverless is Lego. And as a developer, when you're sat on the floor with your bucket of bricks, you're not thinking about building new bricks or molding plastic. You're just thinking about how you assemble what you've got to make your car or your cool spaceship or whatever it is. So for this, you need to embrace the mental shift that you're going to be sticking things together, not building new bricks. And so a lot of the designs I see from people, they're not using enough services. They're not using CloudFront, S3, SQS, DynamoDB. There's still a tendency to want to put too much code into each Lambda function. Now, I believe, as it's been said a couple of times today, that code is a liability, especially my code. But I generally feel that the less code you have, the more testable something is, and the more confident you can be that it will scale. That being said, I think this is a great opportunity to think big. So I'm often surprised that developers who are new to serverless don't take the opportunity to take their functions and throw a couple of thousand invocations at them with Artillery.js or some other framework, because it's very cheap and a very easy way to test what's going on. Similarly, Plan for latency. So just because something takes 2 to 3 seconds when you're testing it, you need to find out what happens if it takes 20, 30 seconds or a minute. See what breaks downstream. Now, I know Lambda went from 5 minutes to 15 minutes last year, but I think there are very few cases where you really need it to run that long. It's better to really aim for brief functions. I think everything we've written runs for a couple of seconds. If you find that it's running for longer than that, you need to really look at it and see if maybe you can refactor and use some services instead. And finally, be stateless. So there's quite a few articles out there hacking on Lambda about how you can make it remember things between functions. It's all very interesting, but I think you get more out of your design if you assume that your Lambdas start knowing nothing in this world. So for non-developers, I came up with this phrase, I can serverless and you can too. And I had an epiphany a couple of months back when I was working with a business analyst. And she's one of these people who is amazing at drawing things on whiteboards. I'm not one of those people. And she took a process flow for this application we were building and did all the nice lines and boxes and everything. I took a photo of the whiteboard. And when I went to look at what it looked like in serverless, it was surprising how much crossover there was from this flowchart diagram to the end application. So the new thing I'm saying is, if you can flowchart, you can serverless. I'm not going to stop until this is a verb, so keep going with me on this. So for product managers and project managers and the non-developer types, there are a couple of other important things. One is that serverless lets you build minimum viable change. And there's no real concept of a version because you have a federation of functions and services running. And this is really, I think, a preferable way to go. And you should really focusing on the minimum unit of deployment because serverless makes it very easy. At the same time, when you're planning big feature releases, there's also a lot less friction in going all the way from designing a customer feature through to the delivery. You can actually deliver fairly large features without fear of fragility when a system's been designed well. Now for business types, this ain't no lift and shift. So it's easy to forget for a lot of people who write the checks and finance these projects, cloud migrations often were a little bit painful. It took a long time, it cost a lot of money. And there's some fear out there that serverless is a bit like that. And I don't think it is. I think for this group of people, it's important to understand it comes with some unique benefits. One is that serverless projects are much, much easier to outsource. So if you work on applications that have NDAs or are very confidential, it's very simple to break them up into small units, farm out the work somewhere, and then reassemble it once it comes back in-house with no one really being clear on how you're using the work. Also, if you work in regulated businesses, doing audits for serverless apps is much easier too because you're often drawing on cloud services, have lots of good documentation, and it's easy to prove what functions are doing and from a security perspective, what they have access to. Now, you need solid IAM skills for this to work, so leave your star permissions at home. And while many applications are not good candidates for serverless, we've yet to find one where at least some portion of the project couldn't be serverless. So in other words, if you find something that has very low latency requirements, there's always email notifications or account administration or some portion of the project that you still can make serverless. And finally, start small. So we started with cron jobs, things that weren't too exciting. There's a lot of low-hanging fruit out there that you can pick off, and it frees up your developers to learn the skills needed to do larger projects. Now, I wanted to shift gears and talk about some actual benefits from real-life projects. So the first thing was fixing the MVP gap. So I talked about this briefly, the idea that when you build an MVP, it's not really fully featured enough to stand up to production. So we built an application called Member Check-in, which this video isn't going to show you. And this was built for gyms, museums, Costco-style businesses, any sort of business where you have a membership card with your face on it. Instead of forgetting the membership card, you just show up with your face. There'll be a reception desk with a computer and a camera, and it'll see you, and it'll say OK or not OK to let you in. Now, when we first built this, this was, in its first iteration, one of our Python apps. It was a browser-based application powered by recognition on the back end. When we shifted it to serverless, we did this to really train ourselves on what we were doing. So we made the front end a Vue.js application, which gave us immediately faster performance because there was less round-tripping back and forth. And we rewrote the back end entirely so that it would be more agnostic to whatever front end we attached to it. Now, this was very fortunate for us because our client changed the project completely. It was no longer called Member Check-in. It was now converted to be an event ticketing app. So if you had concerts or conferences, people, when they buy the ticket, would register their face. And then at the door, checkers would have a mobile phone with an app that would scan you in. So they went ahead and did this, and we had to convert the app to a Flutter application that was deployed to iOS and Android. And we had to get the response time to under 2 seconds with recognition, which was a challenge. And so the real acid test was, this project went quiet for a while. And then one night, I was sat at home, my Slack went crazy, and it turned out they'd just deployed it. And it was used at a conference where hundreds of people were checking in, and suddenly the app went live. And this was the first time we'd actually seen one of our apps survive this kind of accidental production without needing a rewrite. And the weird thing is this wasn't a fluke. Subsequently, we found the same thing happened again and again. So the second thing I'd like to talk about is agility. So we wrote another application, which is in a video that won't work, called Rated 5. And Rated 5 was designed for bricks and mortar businesses where you have live customers going into your business and they have an experience they want to share with you. Right now, they only have Yelp or those sorts of outlets when they have a good or a bad experience. So Rated 5 allowed your customer to walk in, pull out their phone, answer a series of questions, and then give you immediate feedback on if things were going wrong. So in our first incarnation of this, I thought this was fairly simple. This is really just a location-aware form. And what you see on the left is the end user goes to this web app that's pulled from an S3 bucket through CloudFront. They fill out a survey. It goes through API gateway to Lambda, and it's stored in a DynamoDB function. On the other side, you have a business owner that goes to an admin page, and the same thing happens in reverse. They're simply going to Lambda to pull the scores from DynamoDB. Now, the moment this went out to a handful of live customers, we had a flurry of new requests. The first major one was the introduction of photos. We needed to allow photos so that when they were submitted, we could tell what they were and also filter out offensive ones. You'd be amazed what people submit with photos. We also needed to point score the text that was being provided to decide, was it positive or was it negative? So for this, we layered in a line of recognition and comprehend to get that job done. The next phase of iterative development brought in notifications. So if something was going badly wrong, a customer was having a terrible time, we needed to escalate the alert, SMSing out to managers of the business. But also there was an idea that there could be a screen in the back. So if it was a restaurant and you were having a bad steak, there'd be a screen in the back of the kitchen that provided that feedback. So to do that, we had to hook in IoT, so there was no longer somebody F5ing on a browser page. And in the final iteration of this, there was analytics put in at the back, and we had a defensive layer put in at the front to protect us from spamming, DDoSing, that kind of thing. So what was interesting about this project is that we had major scope change. We went from this location-aware form at the beginning to adding all these extra features, including account management, because in the end it wasn't an anonymous app. It was something people could log in and leave their feedback for. And it resulted in very minor code change. The earliest code we wrote didn't change at all. We just added more functions. We were able to run multiple tests in production very easily. And at the end of the project, it ended up being under 1,000 lines of code, which is 5 to 8 times smaller than what we're used to delivering. And the real kicker was that from the very first phone call to the delivery of everything I just showed you was 20 days. Typically, we would have taken more like 3 months. And again, was this a fluke? Not really, because we started to find this was a pattern that in MVPs for startups, you tend to have this wandering roadmap of requests. And it just so turns out that serverless is a very easy way to deliver that roadmap. So finally, let's talk about the problems with AWS and Lambda. Technical limitations. You've got a 5-minute execution limit. You have limited language runtimes you can bring with us. You cannot attach anything to SQS triggers. There's no WebSockets. There's no serverless databases, no libraries or sharing. Right, Chris? Right, Chris? Yeah? No, it's all outdated. So this was last year's list of things that were wrong. So he was having a heart attack back there. And what's amazing about this is that many of the limitations of serverless from a technical point of view are just disappearing before our eyes. If you went to reInvent last year, it felt like a lot of the conference was for us serverless kids, which was great. Thank you, AWS. But I think there are a couple of problems out there that are worth talking about that really aren't technical or even serverless specific. And I've been thinking about these and not talked about them before. But the first is when I go into businesses, I don't know what decade they're in. I talk to businesses that have mainframe, client server, they're getting used to mobile apps, they don't know what cloud is. There's a continuum that goes somewhere from the 1960s to today. And while we sit here with containers and serverless and all these great toys racing off into the future, these businesses that represent the vast majority of people in the country are not moving. And I don't know what the answer is here, but we need to find a better way of bringing them along with us for the ride. The second thing is the social issues around change. So when cloud first happened, there was some resistance because, you have to learn new things and it's a bit inconvenient. Now we're telling people about things where they're scared about their jobs. People are worried that what we're doing will automate them away, and we're introducing technologies that fundamentally change things they're used to. Now, I don't think serverless is going to cause anybody to lose their jobs. We're in a constant need for talented IT people. But it doesn't change the fact that people are alarmed about this, and I see this more and more when I go out to meet teams in other companies. So again, I don't know the solution to this, but I think it behooves us all to make sure all of our IT brethren come along with this journey with us and aren't living in fear that somehow we're working behind their backs to eliminate the positions. So after a year of serverless, what a year. I mean, I'll be the first to admit I didn't expect this to work. So I went from knowing that we could resize images to fundamentally changing the way we develop web apps and mobile apps, my whole business. And we now don't have any EC2 instances except for one stubborn WordPress server that won't go away. But we're working on it, so don't worry about that. This is all very new, and it's easy to forget just how new it is. So there's still new patterns and practices emerging all the time. What this means is that if you find the problem, most often you'll also be asked to find a solution, because at the same time, so is everybody else. It's not like there are many books to go off to learn from. What's going on in serverless is happening in this building right now. Don't hate on containers. So I've noticed a bit of a head-to-head in recent months with the container crowd and serverless. And I think the reality is we both have interesting solutions to the evolution of servers. Now, there are very valid uses for containers. Obviously, serverless is much better, but don't tell them that. And also, follow the leaders. So I put together this Twitter list that I always promote just because I took the top 20 and 30 people out of the community I learned from. I learn from these people every day. They're lots of the people you saw present today. There aren't many areas of technology where you'll find that you can reach out to the people who are the thought leaders in the space, and they'll answer your questions over Twitter. And they are in this building right now. So take full advantage of asking your questions. They'll be more than happy to help you. And that's it. Thank you very much for your time. My name's James Beswick. I'll be at the conference all day, so if you have any questions, I'm very excited to hear what you think.